Hello, everyone. This is Kathy Larson with Rocket Software. Welcome to our D3 Hot Backup for Windows event. I am recording this event. And just a few things before I hand this over to Brian Cram, who has recorded some videos for us to watch. He is on the phone and is available for questions. If you have questions, please type them into the chat, and we'll take some breaks between the three videos and at the end to answer your questions. And let's see, the slide that you see right now is talking about MVU. So this is a continuation from last year. We had a number of events last year. We're going to continue into 2021. And this is the first, and we'll have another webinar in a couple weeks, which will be Hot Backup for Linux. And if you see the URL on your screen, that's the Rocket community. This is a new place where you can come and talk to Rocketeers, your peers, ask questions, and just generally keep informed. And next week, we're going to start a March Madness event, which will be trivia. It'll be a lot of fun, and I'd love for you all to participate. And we will be offering prizes at the end. So if you have not created your free account on the Rocket community, please visit this URL. I'll put it in the chat as well. And I think that is it. So we've got people ready to go. I'm going to turn this over to Brian.
This is a quick tour on how to configure FSI Hot Backup on D3 Windows. Please take a second to read the disclaimer and my bio. What we'll cover today is FSI Hot Backup architecture, D3 Windows system preparation, configuring FSI Hot Backup, things to add to your cold start procedures, starting and testing of FSI Hot Backup, monitoring FSI Hot Backup, and failover in the event of a system failure. Let's talk about the FSI Hot Backup architecture. There are two separate D3 Windows servers involved, one acting as the production or primary server and the other working as the hot backup or secondary. This is FSI replication only. None of the data in the VME gets replicated. The queues are actual files in the FSIDM account. The dictionary level is called FHB, and the data levels vary depending on the role. On the primary, the main data level is FHB, P. On the secondary, the data levels are FHB, S for the main queue, and FHB 1, 2, and 3 for helper control, which we'll discuss later. By default, the FSI Hot Backup secondary runs 3 helpers, and that is the model we'll use for this session, but that is configurable. This is all pole architecture, which means that there are no actual hot backup processes running on the primary. All of the work is done by phantoms running on the secondary, one of which is the main process and the rest are helper processes. The main phantom's duty is to read data from the primary system's FHB, P file, apply that data to its own FHB, S queue, and assign that data to one of the helpers to process. The read of the FHB, P file is done using the FSI OSFI driver, which uses RPC. When an item is pulled over, the main process hashes the fully pathed file name to determine which helper will do the update. Each helper uses its FHB, helper queue number, either 1, 2, or 3, to identify which items to pull out of the FHB, S queue, apply to the database, and delete from the FHB, S and helper queues. Okay, let's talk about preparing your system for FSI backup. First and foremost, the best thing you can do is to make sure you have the fastest connection between the two systems that you can afford. And you need to make your application hot backup friendly. A few things you need to do are make sure that if you have file indexes built on translate correlatives, that the translate file names are fully pathed. While a simple file name may work from one file to another in the same account while you're logged onto that account, hot backup will fail because it's running from a different account and won't know where the translate file is located. The same full pathing of file names is also critical in callx triggers for the same reason. Identify files that do not need replication. This would include temporary work files for reporting or other purposes that are cleared and built whenever you run a report or other process. If you fail over to the secondary and run that report, the file will be cleared and built thereon, so you don't need to clutter the queue. Identify programs and processes that create files which do need to be replicated, and make sure those programs use the L option on Create File. Also, make sure anyone who creates files on the system understands the ramifications of replicating or not replicating that file. Use the set depointer utility to specifically include or exclude files for replication on the primary. This utility is used to modify the depointer of a file as follows. Adding an L to the depointer will tell Hot Backup to replicate this file. We call this DLing a file. Adding a T to the depointer will tell Hot Backup to not replicate this file. Any files that do not bear a DL or DT will be conditionally replicated based on whether you have enabled enqueuing on all files or just DL'd files. On older versions of FSI Hot Backup, it's important that you be aware of special characters in your file names, like asterisk or slashes. If you're on V10 or later, it shouldn't be a problem. If you're on 9.2 or older, contact support and we'll go into greater detail. And finally, make sure to the best of your ability that the primary D3 system gets shut down in an orderly fashion. That would be via the shutdown verb at TCL, not simply stopping the service or pulling the plug. If D3 is not shut down properly, the file control block of the FHBCMAP file might not get updated, thereby causing a sequence error in the queue transaction IDs, which will at best cause Hot Backup to stop replicating and at worst cause overwriting of queue entries, which would necessitate a Hot Backup resync. Okay, now that the system is ready, let's get your data from the primary to the secondary and configure FSI Hot Backup. It's best to do this when you have all users off the system. First, to make a file save on the primary, drag that file save to the secondary and do a restore accounts. Don't use file load, as the DM and FSI DM accounts should be different on each system. If the FSI accounts you're replicating already exist on the secondary, like if this isn't your first rodeo on this Hot Backup pair, please delete any of those accounts before doing the restore. Now, do FSI Hot Backup from TCL on the primary server and select primary. Default modulo of the primary queue file is 1009. I recommend that you make it 49999. Notice that the cursor is to the right of the 9, so you'll have to backspace to clear it. Then answer yes to confirm. On the secondary, do FSI Hot Backup from TCL and select secondary. You'll notice that there are a few more fields here. The first is the default modulo. In my experience, this doesn't need to be as large as the primary, but still larger than 1009. So again, backspace and make it 4999. Number of subqueues is fine at 3, and sleep time of 5 seconds is cool as well. At the primary hostname prompt, key in the DNS resolvable name or IP address of the primary server. Make sure that you have successfully pinged the primary from the secondary using this name or IP. Take the defaults on the remaining prompts and answer yes to confirm. Time to configure both systems' cold start procedures. Make sure you use the user cold start proc or macro in the DM account. If you use the account cold start in one of your production accounts, your settings on the secondary will be destroyed and replaced by the settings on the primary if you ever added that record on the primary or resync the systems. In the primary's user cold start macro, add the FHB on command with an A switch to make sure that enqueuing is enabled when D3 starts up. There's more to do on the secondary. Add these 5 commands to the user cold start. Call X off. This turns off triggers on the secondary. FHB-off left paren A. This makes sure that enqueuing is disabled on the secondary. Set runaway limit 100,000. This will help ensure that large updates can come over unhindered. Remember, there's nobody there to press C to continue if you get an overflow runaway condition on the secondary. Delete FSIDM, FHB, started servers. Started servers is an item in the FHB file that tells Hot Backup that it's already running and may still be present if somebody managed to stop D3 without first stopping the Hot Backup phantoms. This record will prevent Hot Backup from starting, which is bad. FSSC. This actually starts Hot Backup on the secondary. There's a command you can add to the user shutdown macro on the secondary. FHB send message command main stop. This is what you'd type at TCL to stop the hot backup phantoms. It's a good idea to add this to your user shutdown macro in case someone forgets to stop hot backup before stopping D3. Okay, now that everything is set up and configured, it's time to fire it up and test it. Step 1 is to enable global enqueuing on the primary with an FHB on command with the A switch. Step 2 is to start the hot backup phantoms on the secondary using FSSSC. Note that you'll see a message about something being stopped. Don't worry, that's normal. It means that the process that starts the necessary processes ended successfully. The best way to make sure the processes are running is to do a list U or list jobs and make sure you see SS main and SQ main jobs running. If you have 3 helpers, you'll see 4 jobs. Now pick a file that you previously DL'd. My personal favorite is the customers file in the SQL demo account. First do a clear file on the secondary, then do a touch on the primary. In this example, you'd log to the SQL demo account and enter touch customers at TCL. Then do a list customers on the secondary and make sure all the records came over. If all went well with the clear file and touch test, you're now live with FSI Hot Backup. It's a really good idea to frequently monitor hot backup to make sure it's still replicating. There are several things you can do. Use the FHB status command to make sure global and local enqueuing is enabled on the primary and disabled on the secondary. Count the FHB, and FHB, SQ files. Measure throughput. Run an account comparison between the primary and the secondary. We'll cover these subjects a little deeper in the D3 Windows FSI Hot Backup debugging video, which follows this one in the series. Just like automobile insurance, hot backup is something you hope you never need. But when you do, you'll be glad it's there. Simple failover steps can be different from system to system depending on how systems and network are set up. These steps basically are: shut down the primary if it hasn't already crashed and burned. Then on the secondary, use FHB off with the A switch to turn off dequeuing. Use CallX on to enable CallX triggers. Remove or change the cold start procedures related to enqueuing or dequeuing. CallX on to enable triggers. Start printers or phantoms that normally run on your production system, including and especially file saves. Do whatever you do to direct production traffic to the secondary, which is now the production server, like changing the server name and or IP address or DNS. Connect your users to the secondary, which is now the production system. Make sure your users ensure that everything they did in the 5 minutes before the primary server crashed is present on the now production secondary. If you're going to run this system permanently or will be setting up a new secondary, you'll need to configure the server as a primary and follow the resync process that will be covered in the FSI Hot Backup Resync video. Thanks for listening. I hope this was helpful. If you have any questions, please contact Rocket D3 support.
All right, thanks for making that video, Brian. We're making videos like this so that they are short and topic specific so that you can easily revisit the videos, or you can share them with your coworkers. And before we get started with the next video, I'd like to remind everybody Brian's on the phone and he's ready for your questions. So type them into the Q&A or the chat, and I'll check again after this next video.
This is a quick tour of how to monitor and debug FSI Hot Backup on D3 Windows. Please take a second to read the disclaimer and my bio. The topics for this session are monitoring FSI Hot Backup, running a FSI Hot Backup in foreground, the FHBQ item structure, the most common problems with FSI Hot Backup and how to detect and remedy those problems, and a little about when and why to resync FSI Hot Backup. It's a really good idea to frequently monitor Hot Backup to make sure it's still replicating. You should use the FHB status command to make sure global and local enqueuing is enabled. You should see a minus sign next to all files and plus signs next to global and local. Counting the queue files will tell you if anything is stacking up. In the FSIDM account on the primary, you can count FHB, P, and on the secondary, you count FHB, S. If the numbers continue to grow without shrinking, you've got a problem. It is recommended that you put something in place that programmatically counts these queues. It could also be a good idea to measure throughput if you see your queue not shrinking as fast as it's growing. You can do this on a system with nobody on it by waiting until the primary queue is empty, doing a clear file on a very large file on the secondary, doing a touch on that file on the primary, then continue to count the primary queue until it's empty. Note the elapsed time and do the math to yield items per second transferred. Depending on the speed of the pipe, you'll get hundreds, if not over 1,000 items per second. If it's significantly slower than that, it's time to find out why, probably a network issue. If you're ever suspect about the integrity of the secondary's data, you can run an account comparison between the primary and the secondary. We don't have any formal utilities for this, but I wrote some early on to handle account comparison, queue counting, hot backup startup on primary and secondary, as well as some other stuff I can't remember right now. Just reach out to me and I'll get you an account save of my FHB util account. We can go into greater detail about the account's content one-on-one when you reach out. But for account comparison, the utility is FHB check files. This is a basic program that checks every item of every replicated file on one server against the file on the other server for a specific account. It was originally written to run on the slave and select remote files, but it blew up selecting large files over the network, so I re-architected it to only select on the local server. So it needs to run on both the primary and the secondary. When you run it on the primary, it will verify adds and changes. When you run it on the secondary, it verifies deletes. When a discrepancy is found, it is internally logged, then re-verified later just in case the update was in transit at the time of the first test. Also, the program periodically counts the queue and pauses if there's a lot of queue activity. Running the secondary dequeuing process in foreground is a good way to see why a process is failing. To run the failing process in foreground, you must first make sure that the process is not running as a phantom using listu or list jobs. Then issue the appropriate command at TCL and watch the output. To start the main process, the command is FHB_SS.main SSC with the FV options, F for foreground and V for verbose. To start a helper process, the command is FHBSQ.main SSC with a helper number and the FV options. The process will execute, displaying what it's doing to the screen. You can monitor that output until it fails and capture whatever useful information was displayed and go fix the problem. The V option gives you any information provided by tracing at the warning level. This should be enough to point to the problem. If you do need more information displayed, you'll need to set up the trace config item in the FHB file using the update processor or ED, if you're a dinosaur like me. Set the attributes as follows. Attribute 1 equals 5, attribute 2 equals 10, attribute 3 equals 0, attribute 4 equals 1, and attributes 5, 6, 7, 8, and 14. Set the first value to 1 and the second value to 5. Then stop the foreground process by typing an X and restart it. Now you'll get more output when you run the failing process in foreground. Please, please, please remember to turn off the more aggressive tracing when you're done with debugging by renaming or deleting the trace config item and restarting the phantoms, as tracing at this level will fill up log files and degrade performance. Before we get into some common problems, it's a good idea to understand the structure of the FHBQ items. As you know by now, the FSI hot backup transaction queue is a standard D3 FSI file like any other, with the exception that it has an ID1 correlative on the D pointer of the FHB, P data level. When anything is enqueued to the file, it's written with a null ID, and this correlative reads the next number from the FCB and uses that number instead of the null ID. Any updates to that file will be prepended with the attributes 1 through 6. Attribute 1 is the FSA file of files number, which is ignored. Attribute 2 is the transaction type, update, delete, whatever. Attribute 3 is the timestamp, which is the internal date and time of the update separated by an asterisk. Attribute 4 is the fully path file name. Attribute 5 is the item ID. Attribute 6 stores options associated with this operation. At the right, notice the item update has a blank A6 where the create index operation below it contains information in A6. Attribute 7 is where the item body starts. So attribute 7 is the item's first attribute. Attribute 8 is the second all the way down. Here's a list of the valid operation codes that you will find in attribute 2 and what they mean. Please reach out to me if you want a copy of this slide. The common problems that we'll cover today are broken FHB, file handle on the secondary, phantoms won't start on the secondary, overflow runaway condition on the secondary, deleting a DXed file on the primary replicates that file to the secondary, enqueuing enabled on the secondary, incomplete file pathing in collex triggers or indexes defined on translate correlatives, large file resize on the secondary, incomplete flushing of the FHB, files file control block due to the primary host not being shut down properly. Let's look at these one at a time. Broken FHB, file handle. As mentioned in the FHB configuration session, the main process on the secondary accesses the primary's FHB, PQ via RPC reads to the primary, specifically using our FSI OSFI driver. If the FHB, file is already open in SS main and something happens, like D3 is restarted on the primary, that file handle is no longer valid. First test is to list the FHB, file from the secondary using the host name defined in your secondary server config item, SSC, or use the IPv4 address of the primary server instead of that host name. If that works, the solution should be to simply stop and start the phantoms again. But if that fails, try pinging the primary server from the secondary. If pinging works, but listing FHB, fails, there's probably something wrong with RPC. Check the Windows event logs on both servers. Check for some rogue Windows update, whatever. If you can't ping the server by host name or IPv4 address, you have bigger issues like bad DNS or network failure, so call your IT department. The dequeuing phantoms won't start on the secondary. This can happen if the phantoms weren't properly stopped using the FHB send message command main stop command before D3 was shut down on the secondary, or maybe somebody ended or logged off the phantoms to stop them. Either way, there is a started servers item in the FHB file that is removed by the FHB send message command. This item tells FHB that it's already running, so any attempt to start using SSC will simply end without starting the phantoms. You can verify this with ListU and ListJobs to make sure no phantoms are running, and sorting the FHB file to see if that started servers item exists. The simple solution is to delete that item and issue an FSSC command to start the phantoms, then verify success using ListU and ListJobs. Overflow runaway condition on the secondary. This can happen when someone forgets to set a high runaway limit in the secondary's cold start procedure, or a really big transaction came through and the runaway limit value they set wasn't high enough. To detect this, do a where LZ on the secondary phantoms and see if they have any OVF1 main in the return stack. Then tandem that PIB, answer C to continue, then escape lowercase x to terminate the tandem. Don't forget to update the set runaway limit command in your cold start procedure on the secondary. There are several bugs in older versions of FSI hot backup, like special characters in file names and others. So here's my plug to make sure that you upgrade D3 to the most current version whenever you can. In the interest of time, I'm not going to go into all of them, so we'll just pick one that stood out. Deleting a DXed file on the primary can enqueue a create file of that DXed file on the secondary. This was a bug that was fixed at some point, and I don't remember what D3 versions contain that fix. It's easy enough to rectify. Just do a list files on the secondary account or accounts and look for a file with a DX dictionary level only. When you find it, do a delete file on the secondary to get rid of it. And queuing enabled on the secondary. This can be a problem in two ways. The first being that there is no FHB, P file defined on the secondary, and D3 is attempting to enqueue updates to that file. This will result in a flood of errors in the Windows application event logs. If the FHB, P file does exist on the secondary, that can also be a problem if there is no tertiary server to dequeue this file, so it will continue to grow, causing performance issues and, in extreme cases, chew up all the available disk space in Windows. Easiest way to detect this is to do an FHB status command and look for any plus signs, either for all files or global enqueuing. And then first thing you need to do is issue the FHB off command with an A switch to turn off all enqueuing. Then you need to make sure that the cold start procedure doesn't contain the FHB on command and does contain the FHB off command. Next, you should stop dequeuing phantoms if running, delete FHB, P file if it exists, and reboot D3. After that, you should clean out your Windows application event log if it's flooded. Incomplete file pathing and callx triggers or indexes defined on translate correlatives. When you're running a callx or using an index based on a T correlative in your application, full pathing of the file references is not typically necessary because the callx or index is on a file in the same account in which your application is operating. The problem is that hot backup is running out of the FSIDM account, not your application's account. So the callx and correlative have no idea where the file is, so the update will fail and cause the helper phantom to terminate. The best way to detect this is to run the helper in foreground with tracing configured. It's also helpful to sort the FHB helper queue to find the FHB, S item ID on which the helper is failing and CT the item. This will give you a clue as to which file has a callx or T correlative index that has unpathed file references. To get past this, go to the primary and fix the callx or T correlative to use fully pathed file names. Once that's complete, you can fix the secondary in one of two ways. Number one, delete the offending FHB, S item, then stop and start the phantoms and update the file or index manually, or do a hot backup resync. The resync is more time consuming, but recommended because it removes any chances of errors or omissions. A large file resize on the secondary is hanging one of the helpers. This happens when you resize a large file on the primary using NT resize with the I option to resize immediately. This will enqueue an S-type update that will cause one of the helper processes on the secondary to do the same thing. The problem is that this could take a very long time and items will stack up in the FHB, S queue waiting for the helper to finish the resize. To detect this condition on the secondary, count the FHB 1, 2, and 3 queues and see which one is stacked up. Sort that helper queue to find the transaction ID on which it's stuck. CT the FHB, S file for that transaction ID, which will show you the S in attribute 2 and the file name in attribute 4. Note the new modulo of the file in the first value of A6. You might need it later. Now to verify that the file is still being resized, you need to get into the monitor debugger and run an FSCK on the file, since immediate resizes in the FSI do not update the file that NT list resizing uses to report resizing in process. If you don't know how to use the monitor debugger, raise a case with support and we'll guide you through it. It's not something we publish because you can really do some damage if you're not careful in there. It would be a good idea to do NTP info on the helper PIB a few times and see if the thread's CPU or memory is changing. If not, the PIB is stuck. Okay, how do we fix this? Well, if NTP info shows that the PIB is moving, you could just wait it out. But if it's stuck or your patience is exhausted, you'll need to fix it manually. So stop the hot backup process on the secondary. If the helper doesn't respond to the FHB send message command, you'll probably have to end the phantoms manually and delete the FHB started servers item. Then delete the create index transaction from FHB, S and the FHB, helper file so it doesn't try to do this again. Then delete and recreate the file being resized on the secondary. Then restore the newly created file from a tdump made on the primary. Then start the hot backup secondary process again and monitor. Incomplete flush of the FHB, P files control block. This is one I haven't seen in a while, but should cover it anyway. This happens when the primary experiences an improper shutdown, be it killing the VME process, pulling the plug, whatever. What happens is that D3 does not have a chance to flush the FHB, P file control block to disk. The FCB contains the FHB, P file's next sequential ID. So when this happens and enqueuing resumes, the IDs are lower than the previously enqueued items. Since the main secondary phantom reads the FHB, P items sequentially using the last processed ID items, it will not detect the items now being enqueued by the primary until the primary enqueuing catches up with that last processed ID number. The symptom you're looking for is the FHB, P queue growing with no evidence that there is any dequeuing happening on the secondary. So sort FHB, P and compare the lowest number to the numbers shown when you sort the secondary's last processed items. The safest thing to do at this point is a resync. You could do a watch sort on the last processed IDs and note whether the secondary's last processed IDs are changing. If they are not changing, you may have caught it in time and could do the following. Stop the phantoms, determine the lowest FHB, P item ID, subtract one from that ID, use the editor to put that resulting number in all the last processed items, and start the phantoms again. But the problem is, if the last processed IDs aren't changing, you can't be sure if it's just because you caught it in time or there just isn't anything being enqueued, so no dequeuing is taking place. Much better to resync. On the subject of hot backup resync, chances are once you've found and solved whatever problem got you here, you're going to need to resync the secondary to the primary. We'll talk about that in the next video in the series. Thanks for listening. I hope this was helpful. If you have any questions or problems, please contact Rocket D3 support.
All right, thanks again, Brian. Another great video. We have got one video left. It's less than 4 minutes, and I would love it if people would put in questions in the Q&A or chat since Brian is here with us on the event. And I will remind everyone that look for a recording in the next couple of days in your email, and feel free to share that. I'll also include links to the individual videos if there's one video that you want to watch again or share. And let's get started with the last video.
Hey, Kathy, before you start the last video, Brian Cram here. How you doing?
Hi, Brian. What's up?
We've had one request, and I've had several others for the transcripts, but the PowerPoints and the scripts I use to record these.
Yes, sir.
We're working on getting those in a way that we can get them to people. The PowerPoints are too large for our mail server. Particularly, my pal Todd out there wanted a copy, so we're working on that for him. I sent those over to you. If there's a way you can compress them, that would be great.
All right, I will work on that, and thanks for sharing.
Thank you, ma'am. Bye-bye. This is a quick tour of how to resynchronize FSI hot backup on D3 Windows. Please take a second to read the disclaimer and my bio. In this session, we're going to talk about resynchronizing the hot backup primary and secondary servers. In case it's not obvious, when we talk about resyncing, we mean to delete and refresh the data on the secondary server from a primary server file save. First thing you do is to stop the dequeuing process on the secondary if it's running. To do that, you can issue FHB send message command main stop command, then monitor list jobs and list you until they stop. If for some reason they don't stop, you'll need to end them like a normal phantom by issuing the end command with the pib and user as which the phantom is running. If that doesn't work, you'll need to do a forced log off of the pib and a phantom reset of the pib. In either case, after the jobs are not running anymore, delete the FHB started servers items so FHB will not think the phantoms are already running when you go to start them again later. Next thing to do on the secondary is to clear the queues by doing a clear file on the FHB, S, 1, 2, and 3 files. Now, shifting your focus to the primary system, you need to kick all the users off the system, turn off enqueuing by issuing the FHB off command with a switch, then clear the queue file by doing a clear file FHB, P command, then start enqueuing again by running the FHB on command with the a switch, then start a file save. At this point, you can let the users back on the system if you need to, but better to keep them off until the resync is complete. When the file save is complete, drag it over to the secondary. Then on the secondary, Do a delete account on all of your replicated accounts, remembering to leave ours alone, FSIDM, maybe MVSP, maybe others. If you have some history accounts or other stuff that is not touched, you can leave them there too. Then attach to the file save tape and do a restore accounts. This will put back all of the deleted accounts in the same state they were in on the primary when the save was done. After the restore accounts is complete, go back to the primary and sort the FHB, P making note of the lowest item ID for that file. If the file is empty, edit and file an item in a replicated file to force an entry into the queue and do the sort FHB, P command again. Back on the secondary, you now need to set all of the last processed ID items to whatever it takes to have the secondary pick up at the right spot. That value will be whatever that lowest FHB, P item ID is, -1. So if the ID was 1, 2, 3, 4, 5, 6, 7, you'd use 1, 2, 3, 4, 5, 6, 6. So the process is select FHB equals last, and this should give you 7 items selected. Edit FHB. And each of the 7 items, replace the number that's there with the lowest ID -1 number. When done, verify by issuing the sort FHB command shown in the slide to make sure all items were correctly updated. Once that's done, it's time to start dequeuing again by issuing the FSSSC command. Then do some list use and or list jobs until all 4 phantoms are started. Then monitor hot backup for a while using the techniques previously discussed to make sure the primary queue is draining. Thanks for listening. I hope this was helpful. If you have any questions or problems, please contact Rocket D3 support.
All right, we are at the end of our event, and I wanted to remind everybody you'll see a recording in a couple of days. If you think of questions later, definitely shoot me an email or Brian, klarson@rocketsoftware.com or bcram@rocketsoftware.com. While this last video was playing, we decided to put the PowerPoints and the transcripts in the Rocket forum. So please visit the forum and set up your free account. Community.rocketsoftware.com is the link. And once you've set up your free account, you can visit the D3 forum, and the PowerPoints and transcripts will be in there soon. And I'd just like to say thanks for spending part of your day with us, and enjoy the rest of your day. Bye, everyone.